Okay, in this example, we're just going to work through, in this video, we're just going to work through a couple examples of simplifying radicals. So this one, what we're going to work on is letter E in the notes, if you are following along with my notes. We're just going to, for now, we're just going to ignore the 2xy squared on the outside of the radical, and I'll show you how we're going to deal with it later. So we're just going to look at the 300x cubed y to the 5th inside. And what I'm first going to do is I'm going to break this up. I'm going to make a factor tree, but I'm going to break it up into the numbers and then the 3 kinds of variables. So 300, x cubed, and y to the 5th, okay? And we know that factor trees are supposed to find things that multiply together to give you the number above it. And this is true. 30 times x cubed times y to the 5th is equal to 300 x cubed y to the 5th. So now I'm going to break down 300 as far as I can. So I can break it down to 30 and 10. The 30 I can break down to 3 and 10. The 10 I can break down to 2 and 5. Then this 3, this 2, and this 5 are all prime, which means I can't break them down any further. The 10 breaks down to 2 and 5, which are also prime. The x I'm going to break down all in one step. X to the 3rd power is x times x times x. And all of these x's are prime because we can't break them down any further. And then the same with the y. 1, 2, 3, 4, 5. Y to the 5th breaks down to 5 y's. These guys are all prime too. It's kind of getting messy. But I'm going to change colors to red now, and we're going to start looking for pairs. So the first thing I notice is that over here in my number section, I have a pair of 2's, which is nice. I also have a pair of 5's. So I have 2 pairs. I also have 1 pair of x's. Then I end up with 2 pairs of y's. One right there, and one right there. Okay. So now we're going to do the final steps of simplifying radicals. So anything that was a pair gets to come out of the radical. So I get a 2 outside, a 5 outside, an x, a y, and a y. Those are all multiplied together. And then what's left inside the radical is whatever is prime but didn't form part of a pair. So I have a 3, an x, and a y, and those are also multiplied together. So this is where we need to come back to our original problem and remember that we still have a 2xy squared at the top. And that is going to be multiplied with these other numbers outside the radical. Now we're just going to multiply things together and combine any terms that we can. So I have a 2 times a 2 times a 5, which is going to be 20. I have an x times an x, which is x squared. Then I have y squared times y, which is y to the 4th. And then underneath my radical, I have 3xy. Okay, so this is considered the simplified version of the original radical. Basically, simplified means that you took as much out of the radical as you could without, going into fractions and stuff like that. So that's how we're going to leave E simplified. Let's do one other example. We're going to do an example this time where we're dealing with something that's not a square root. We're actually just going to do h. H is considered a cube root because the number on the outside right here is a 3. The index is 3. So I'm going to start the exact same way. I'm going to break this into numbers and all of my variables. Okay. I'm going to start by breaking down these variables really fast. 1, 2, 3, 4, 5, 6, 7, 8, 9. Man, that's messy. So if I have 9 u's and I multiply all of them together, I get u to the 9th. The t is going to be 7, so 1, 2, 3, 4, 5, 6, 7. All of these are t's. And just so you know, if you found different ways to do this, it's a little bit shorter. You don't have to go through and make these trees the way that I have every time. 32, I'm going to break down into 2 and 16. 16 can break down even further to 4 and 4. And both of these 4's can break down into 2's. 2 sets of 2's. I'm going to circle all my numbers that are prime. I'm not going to circle the variables just because it's going to get super messy if I do. Now I start looking for trios of numbers. So because my index is 3, I'm looking for trios. So I see one trio of 2's right here. I also see a trio of t's right here and another trio of t's right here. And then with the u's, I should end up with 3 trios of u's. Okay, so now I'm going to write my final answer. So anything that was part of a trio gets to come out of the square root. So I have a 2, I have 2 t's that were part of trios, and then I have 3 u's, right? And then what's still in the radical, remember to include that 3 with the index with the radical, is that I had 2 2's that were left over, and I had a t that wasn't part of a trio. So I'm just going to simplify and rewrite these a little bit nicer. So I have 2t squared u cubed, and then still inside the radical or the cube root is going to be 4t. That's going to be the final answer on that simplified radical. So just a couple of things to be aware of. Make sure that you check out what your index is. Like in this case, it was 3, so we knew we were looking for trios. And also make sure that you rewrite your index down here in your final answers.